It has the definition for a ratio and a proportion to start us off. So a ratio is just a comparison of quantities. Ratios can be represented with a colon in between the two quantities or as a fraction. So you'll see it either way. A to B or A over B still means the two are in comparison. C to D and C over D. Here they are with numbers if you need an example in that way. So the first number is the top, second number is the bottom. When you're doing ratios, it doesn't really matter unless there's a story problem behind it. A proportion is an equation stating that the two ratios are equivalent. So that means there will be an equal sign between the two fractions. All right, so let's practice the first two. This is review from middle school. The second two are somewhat new to you. It says, solve the proportion. This is what a lot of you were trying to do when we were multiplying fractions. This is the butterfly method, or cross multiplying.
The LCO.
Okay? So this is when you're going to draw the little wings on your butterfly and multiply it diagonally, not when you just have two fractions multiplied, when you were doing that before. So we're going to multiply the diagonals. So we're multiplying 12 times x, and we're multiplying 9 times 4. Does it matter which diagonal you write first?
Yeah. No.
No. I usually write the one with the variable first because I like my variable to end up on the left, but it doesn't matter which way you write it. So one diagonal is x times 12. You can write that as 12x if you'd like. Equals the other diagonal, 4 times 9. Simplify what you can, so 12 times x doesn't simplify much. What's 9 times 4? Okay. How do we solve this thing from x from here?
Divide 12 on both sides.
Okay. Divide the 12 off on both sides. The 12s cancel on the left, leaving us with x equals what?
3.
Delightful. All right, you try number 2 then. Solve for n. So you multiply the two diagonals. 5 times n equals 4 times 10. Solve for n and you end up with 8. All right, let's look at 3 and 4 then. In number 3, there's actually 2 ways you can solve this. I'm going to show you both, and then you're going to pick which one works for you. So method 1 is to write the constant over 1 so that we have a fraction equals a fraction. And then cross multiply like we were doing above. That is one option. So then I'd be doing 1 times x minus 2 and equals 3 times x, or 3 times 6. The only thing about this method is you have to make sure you distribute whatever number was on the bottom. Some people forget that in this method. So I would be doing 1 times both pieces, x minus 2 equals 3 times 6. It is a 1, but you would distribute it, so we don't change for this one. X minus 2 equals 3 times 6. What's 3 times 6? Okay, and then how do we solve for x from there? Delightful, and what do we get? X equals 20. That's one method. Here's the other one. I'm going to rewrite it as if I was starting from the beginning. We can clear our fraction when we start if you don't like fractions at all anyways. So if we have this divided by 3, how do we undo that? Okay, so we can multiply both sides by 3. They'll cancel on the left, and we get x minus 2 equals 6 times 3, which is 18. And you'll see we're at the exact same step. It doesn't matter which way you get there, and then you'll finish solving. We'll add the 2 to both sides, and we still get x equals 20. So whatever route you want to take works for us. Just make sure you pick one and you're consistent so that you're not messing it up. All right, in number 4, we've got x divided by 5 plus 3 equals 18. We can't get rid of what's touching x until there's nothing left on this side. So we can't touch the 5 yet. But what has to go first? The 3. We're trying to get x alone, so that term has to be by itself. How do we get rid of a plus 3?
Subtract.
Okay, where are we subtracting it from? The 3 and the 18. Now we've got x over 5 equals 15. You finish it from there. Yes, we multiply both sides by 5 to get rid of that denominator so that we get 5 times 15, which is 75. All right, flip the page. I think we have 4 examples left to do. It shouldn't take us very long. All right. At the top is another definition for us, which is a rate.
What time do we get out?
So a rate is a ratio, which remember was a two quantities being compared. I forgot my I here. That's supposed to be quantities, not quantitates. A ratio of two quantities using different units. So the example I gave was 10 meters per second. What's another one you know of that's like a common ratio rate that uses two different units?
Oh, pounds and kilograms.
So like the example I gave was 10 meters per
miles.
second. What's another something per something? Mary?
Miles. I said miles.
Miles per hour. What's another one? Jonathan?
Liters per minute.
Okay. If you're doing like draining
Kilometers.
pools and stuff, a lot of times you say like gallons per minute, that kind of thing. So anything that's like 1 unit per another thing. Okay? That is a rate. It can be written in 3 different ways. Most commonly, you'll see the 10 or the number out in front and then the units stacked on top of each other. You can always put the number in the top unit because this is really like a 10 over 1. So you could write it this way. I don't like it that way very much. Or you might see it as whatever the number is and then the unit slash the other unit. That's usually how you see it if it's typed in something because computers don't usually type fractions well. All right, we're going to actually skip 5 first and do 6 because that example is a little bit harder. So let's do 6 first. It says, convert 2 ounces into grams and then round your answer to the nearest whole number. The last page of your packet has a bunch of different conversions for you. Is there anything on this page that tells us how we convert ounces to grams?
Multiply by 28.
All right, this thing right here says 1 ounce is 28.35 grams. We're going to use that fact to help us solve this question. All right, so start with what you're given. 2 ounces. I always put it over 1 so that I'm starting with a fraction because we're going to put a bunch of fractions after them. So 2 ounces over 1. You can put anything over 1 and it doesn't change it. Then I'm going to multiply it by what my conversion is. If I want ounces to cancel out in my next fraction, should I put it on the top or the bottom? The bottom. Because if we have ounces on top and bottom, they're going to cancel each other out when we multiply across. And we're going from ounces to what?
Grams.
Okay, so grams is going to go on top, and we're going to get a final answer in grams. All right, so we said, what was the conversion? 1 ounce.
It's 28.35.
Okay, so 1 goes by ounce. 28.35 goes by grams, because that's how it was in the unit conversion. We're going to multiply across on the top and across on the bottom. So 2 times 28.35 gives us 56.7 over 1 times 1 is 1. All right, are we done?
No.
Why not?
We take away the fraction.
All right, so that would give us 56.7 grams. Are we done now?
No. No.
Yeah.
Sam?
Need to round it to a whole number.
Oh,
Direction said round to the nearest whole number. So what will this round to?
57.
57 grams. Make sure you've got a unit on there. All right. The delta math that you do next time, not today, is going to be a lot of these one-step conversions. So you're just going from one thing to the other. But you might also have something like number 5, where it says convert 10 yards into meters. Go to your conversion chart. Is there any direct route from yards to meters? So let's start with what we have. 10 yards over 1 times. All right, we said we're going yards to feet first. Is yards going to go on top or bottom?
Bottom.
Okay, we need that to cancel off. And we're going to feet. From here, my yards units are going to cancel. Do we want a final answer in feet?
Yes.
No.
No, so we have to do another one. Is feet going to go on top or bottom if we want it to cancel? Okay, and what are we trying to end in? All right, this is going to give us an answer in meters because the feet are going to cancel. And let's see what we get. All right, what was the conversion from yards to feet? Is there 3 feet in a yard or 3 yards in a foot?
3 feet in a yard.
3 feet in 1 yard. All right, what's our conversion from feet to meters?
2.8.
Next to meters or next to feet? So you're going to your sheet, feet to meters. 1 foot is 0.305 meters. So we're putting a 1 next to foot and 0.305 next to meters. All right, a 1 next to foot, a 0.305 next to meters. Let's see what we get in meters. Multiply a cross on the top and a cross on the bottom. We're lucky here that the bottoms are all 1s. That doesn't always happen. So 10 times 3 times 0.305 is 9.15 over 1 times 1 times 1 is 1. Okay, that gives us 9.15 meters. Are we done? What do we have to do now?
The nearest round to the nearest.
Okay, so what's our answer rounded to the nearest tenth? 9.2 meters.
Okay, you guys know that there's like a chart up here that you guys can use if you're not sure where the place values are.
Right, so I didn't tell you what to round to, so you could have picked anything to round to. We needed hours to cancel, so hours went in the bottom of the next fraction. We end in days. Multiply a cross on the top, a cross on the bottom. Simplify. You could have put 0.8, or if you rounded to the nearest whole number, it would have been 236.
Are you allowed to use your calculator?
Absolutely. All right, and then for number 8, was there a direct conversion from pounds to kilograms?
No.
Well, we all have the same sheet of paper, so I'm confused why some are saying yes and some are saying no. Do we have a direct conversion from pounds to kilograms? 1 pound is 0.454 kilograms. Okay? So we can go right from pounds, canceling out, to kilograms. What number is going where here? Where's the 1 going?
Underneath.
Okay, 1 pound is how many kilograms?
That was
0.454. So we multiply a cross on the top, a cross on the bottom. Whoops, sorry. The pounds units cancel, and we're going to end up in kilograms. So 165 times 0.454 is 74.91 over 1. And then you could have rounded to whatever you wanted because I didn't specify. So you could have left it like that. You could have rounded to 0.9 or just left it as 40 or 75. Questions on those?